Welcome again. Today I will solve the problem based on partial differential equation of order 1 and degree 1 with the help of the Lagrange methods. So, questions. So, I am writing questions here. Solve. I will try to solve these questions. The first problem is x, z, x plus y into p plus z x minus y into q equal to x square plus y square. All these problems are of similar kind, so I am writing them together. So this is your second question. Third problem is plus x plus zy q equal to x square plus y square. Then the fourth problem, x y square plus z p minus y x square plus z q equal to z x square minus y square. And the fifth problem is z square minus 2yz minus y square p plus xy plus zx into q equal to xy minus xz. Okay, these are the 5 questions. All these questions are similar to each other and they belong to the same class. So let us start with the problem number 1, solution of the first part. Here the auxiliary equation, Lagrange auxiliary equation will be, equation is dx upon z into x plus y, then dy upon z into x minus y, and then dz upon x square plus y square. Now in these type of questions we will use multiplier. Multiplier in the sense, as we know that in proportion, if you multiply the numerator by some multiplier or the denominator, then the ratio will be equal to all these 3 terms. So let us take some multiplier. In the first case, suppose that let us take multiplier as I am taking multiplier x here and then y here, and at this place we are taking the multiplier z. And the second case, then we will try to take some another multiplier. So taking the multiplier, say I am multiplying the first term by x, second term by minus y, and third term by z. Then now if we take these multiplier, then all these 3 terms will be equal to, then all terms are equal to this term, because you know that in proportion, if you multiply numerator or denominator and then if you add all the terms, then the ratio will be equal to all these 3 ratio. So let us multiply the numerator by x. So this will be your x dx and its denominator will be x into z. Then we will have x plus y. Now if you multiply this one by y, we will get minus y dy, and here we will get yz x minus y. Then the third term will be, if you multiply this term by z, we will get z into dz, and here we will get z into x square plus y square. Now what is our aim? Our aim is to reduce this term equal to 0. If we are able to reduce this term to 0, then if you cross multiply this term to this term or this term or this term, then you will see that your numerator will be equal to 0. Now if this is your 0, then this 0 will be equal to, then this term upon 0 will be equal to these 3 ratio. So that means our x dx minus y dy plus z dz will be 0. So let us see whether it is 0 or not. Now the first term will be your x square into z, and here you can see that. So this is your x square into z, and okay, then it is again x square into z, so it is not going to cancel. Then let us see next one. This is your xyz, and here you can see that this is again your xyz. As we have to multiply this term by minus sign, so we will have here minus sign. So you can see that your xyz is cancelled with this term. Here you will get plus yz square, and here we are getting again plus zy square. So let us take multiplier here as minus z. Let us see what happens. If we take minus z, then let's see. Now the first term will be your x square z, and here we have minus x square z, so it will be cancelled. Then the next term will be your xyz. Now xyz will be cancelled with this term. Then this term will be your plus y square z, and this is your minus y square z. So you will see that your denominator is 0. So this is the beauty of these multipliers, and these multipliers are taken in such a way that your denominator remain 0. So on cross multiplying or on taking this term and this term, you will see that your x dx minus y dy minus z dz is equal to 0. So on integration, the integration of x will be x square by 2, integration of y will be y square by 2, and integration of z will be your z square by 2 equal to, say, some constant c by 2. So the first solution will be x square minus y square minus z square equal to c. So this is your first function, say u. So we have the one solution. So now let us take multiplier as this is your one set of multiplier, and suppose that now we will take some another multiplier, and let the multipliers are, and now we have to think what type of multiplier we have to take. So if you take, so this is your first solution. Let us write it here as x square minus y square minus z square. So this is your first solution, and we will cross check it with our solution. So now let us take multiplier as, now suppose that, now let us multiply this term by y, and say this term by x, and then this term by z. I have just guessed these values, and I am not aware, I am not known that whether these are correct or not. I am not sure that whether these are correct or not. Here I am not sure that whether these values are correct or not. So let us see. If you multiply the first term by y, then all terms are equal to. Now let us see what happens. The first term will be your y dx, and here you will see the yz upon x plus y. Now if you multiply the second term by x, then we will get x dy. Okay, that is okay. Now this will be your xz, x minus y. Now if you multiply the third term by z, we will get z dz, and again here we will have z into x square plus y square. Now let us see what happens. Now the first term is your xyz, and this is your minus xyz, so it is cancelled. Now the second term will be your y square z, but it is not cancelled with this one. So if you take minus z here, then let us see what happens. Now this xyz will be cancelled with this xyz. The second term is your y square z. This will be cancelled with this one, and this is your x square z, and it will be cancelled with this one. So that means this multiplier will work. So taking the multipliers as y, x and minus z. If we take these type of multiplier, then this term will become 0. So this is your 0. Now what is the problem? That you have to guess these multiplier at every time for solving such type of problems. So again, on cross multiplication, we will get this term equal to 0. So on integration we will get, okay, before integration we can combine these two terms. On combining these two terms we can write them as d of xy, because if you take y as a constant then we will get y dx, and then if you take x here then we will get x dy. So on integration we get xy, then integration of z will be z square by 2 equal to some another constant, say c1. So we have two set of solution, two set of functions or two set of constants. Thus our solution is therefore solution is some function of, the first solution was x square minus y square minus z square, and the second solution is xy minus z square by 2. So this is your answer. So this is your solution of the first part. Okay. Now the second part. Let us solve the second part. And in the second part we have mz minus ny, and then we have nx minus lz, and then ly minus mx. So now let us guess the multiplier. First time let us take multiplier lm_n. Now if you take the multiplier lm and n, then now each of your term will be equal to ldx plus mdy plus ndz. Now here the first term will be lmz, and then this will be your minus lny. Now this will be your mnx, then we will get mlz, then the third term will be nly, then nmx. Now you can see that all these terms are cancelled to each other. So that means this denominator is 0. So you can write 0 here. So on cross multiplication we will see that this is equal to 0. So on integration our first answer will be lx plus my plus nz equal to c1. So this is your first solution of this auxiliary equation. Now change your multiplier. Now suppose that the multipliers are, let us multiply this term by x and this one by y and this one by z. This is just a trial. I am not sure that whether this will work or not. Just you have to guess it. If it works, then it is good. If it does not work, then you will have to change the multiplier. So now suppose that these are the multipliers, then each of these term will be equal to, let us see what happens. Now this will be your z dz. Now in the denominator we will have, the first term will be xmz minus nxy, the second term will be nxy minus nyz, and the third term will be lzy minus mzx. Now you can see that again this multiplier works, because as x and z will be cancelled with this term. So all these terms are cancelled with each other. So again your denominator is 0. As denominator is 0, so on cross multiplication we will get x dx plus y dy plus z dz equal to 0. Hence on integration your solution will be x square by 2 plus y square upon 2 plus z square upon 2, say another constant, equal to c1 by 2. So from here you will get x square plus y square plus z square equal to, say, some another constant c2. So this is your second solution. So thus your final solution will be equal to, the first was lx plus my plus nz, and the second is x square plus y square plus z square equal to 0. So this is your solution. Then the third part. Now for the third part, we have dx upon y minus zx, then dy upon x plus zy, then dz upon x square plus y square. So this is our third part, and for this part let us guess our multiplier. So this is your y minus zx, x plus zy, and x square plus y square. Okay. As you can see that here we are getting x square plus y square, and this type of term let us find out this type of term. For that, if you multiply this term by y and this term by x, then we will get this type of term. So let us multiply the first term by y and second term by x and third term by minus 1. Let us see what happens. So now the first term will be y dx plus x dy and minus dz. Now here you will see that this is your y square minus zxy. Now here you will get x square plus xzy and minus x square minus y square. Again you will see that this y square and y square is cancelled, x square and x square is cancelled, xzy and xzy is cancelled. So that means this is your 0. So on cross multiplication we will get y dx plus x dy minus dz equal to 0. So on integration we will get, so before integration we can combine these two terms. So we will write it as d of xy minus dz equal to 0. So on integration we will get xy minus z equal to some constant c1. So this is your first solution. Okay, so this is your xy minus z equal to c1. Now let us guess the another multiplier. Now if you take the multiplier as x, y and z, then let us see what happens. So now the first term will be x dx plus y dy plus z dz upon this first term will be your xy minus zx square, then the second term will be your xy plus zy square, and the third term will be your z into x square plus y square. So you can see that your z x square and zy square are cancelled. So this zx square is cancelled with this term, but remaining term will not get cancelled. So for that, let us take multiplier as x minus y. If you take minus y, then let us see what happens. Now here we will get minus y, and this will become minus xy, and here we will get minus zy square. Now you can see that this is your minus zx square. Now this is your minus x. This is your xy. This is your minus xy. This is your zx square. This is your zx square. Here we are getting minus zy square. Here we are getting plus zy square. So that means this multiplier will work. So in the denominator we will get 0. So here this term is 0. Now if this is 0, so on cross multiplication we will get x dx minus y dy plus z dz equal to 0. So on integration we will get x square by 2 minus y square by 2 plus z square by 2 equal to some constant c2 by 2, or we can say that our answer is x square minus y square plus z square equal to some another constant c2. Thus our solution is, f of, the first solution was xy minus z, and this is your x square minus y square plus z square equal to 0. So this is your solution in this case. Now let us solve the next problem. That means the next part, the fourth part. In this part we have dx upon xy square plus z, then dy upon minus y x square plus z, and dz upon z into x square minus y square. Now guess the multiplier. Now let us guess the multiplier. So as you can see that here we are getting x square minus y square. So one possibility is that multiply this term by x and this term by y and try to subtract. So if you take multiplier as x in this case, y in the second case, and 1 say in the third case, then let us see what happens. Now the each term will be equal to x dx plus y dy plus dz upon, now this first term will be your x square y square plus x square z. Now the second term will be your minus y square x square minus y square z. Now the third term will be zx square minus zy square. Now you can see that this term is cancelled. Now to cancel this term, here we should have minus sign. So let us take multiplier minus 1 in place of 1. So if you take multiplier minus 1, then we will get minus 1 here and here minus 1 and plus 1. Now let us see. This x square y square will be cancelled with this one. X square z is cancelled with this one. And then y square z and this z y square will be cancelled. So you can see that this whole denominator is 0. So this is 0. So on cross multiplication we will get x dx plus y dy minus dz equal to 0. So we can write it as d of xy minus dz equal to 0. So on integration we will get xy minus some z equal to c1. So this is your first part. This is your first solution. I think this was your fourth part. Okay. This is your fourth part. Then let us guess another solution. I think the first solution is similar to the previous one, which is your xy minus z equal to c1. Now let us guess the another solution. Now take the multiplier as, now let us, if we take this x in the numerator, that means if you take the multiplier 1 by x or 1 by y and 1 by z, then each of the term will be equal to, now this in the numerator we will have dx upon x, then in the denominator we will have dy upon y, and then in the denominator, in the third term we will have dz upon z. Now let us say in the numerator we will have here, because we have taken this x in the numerator, so we will have y square plus z. We have already taken this minus sign in the numerator, so we will have plus x square plus z, and here we will get x square minus y square. Now to cancel this x square with this x square, let us take this 1 by y as multiplier minus 1 by y. Now if we take this multiplier as minus 1 by y, so we will get here minus sign, minus minus plus, and this will become your, now you can see that if you take the multiplier as 1 by y, then if you take the multiplier as 1 by y, then this will be your dy upon y, and here we will get minus x square minus z. Now the multipliers are 1 by x into dx, 1 by y into dy, 1 by z into dz, and then in the denominator we will have y square plus z. Here we will have minus x square minus z, and here we will get x square minus y square. So now you can see that all these terms will be cancelled with each other. So this is your 0. So again on cross multiplication we will get dx upon x plus dy upon y plus dz upon z equal to 0. So on integration we will get log x plus log y plus log z equal to log c2, and say your answer is, now this will be your log a plus b, log a plus log b plus log c, that means log abc equal to c2, log c2. So your second solution will be xyz equal to c2. So your final solution will be, thus your solution will be xy minus z and then xy into z equal to 0. So this is your answer. So this is your answer. Now I am not solving, I have already solved this fourth part. Now let us solve the fifth part. In the fifth part we have the function as, the auxiliary equation as dx1 z square minus 2yz minus y square. Then this will be your xy upon xy plus zx, and then here we will have xy minus xz. Now let us choose the multiplier. And let us choose the multiplier. Now first time let us guess the multiplier as xyz, and let us see whether these multiplier work or not. So the first term will be your x dx, the second term is your y dy, and the third term is z into dz. And here we will get x z square minus 2xyz minus xy square. For the second term we will have xy square plus xyz, and for the third term we will have xyz minus xz square. Now again you can see that this denominator is 0. Now if this denominator is 0, then we will have x dx plus y dy plus z dz upon 0, and on cross multiplication we will get x dx plus y dy plus z dz equal to 0. So on integration we will have x square by 2 plus y square by 2 plus z square by 2 equal to some constant by 2. So this 2 will be eliminated, and the first solution is x square plus y square plus z square equal to, the first solution is x square plus y square plus z square equal to c1. Now let us guess the second solution. Okay. So this is your one solution, and for the second solution, now guess your multiplier. Now, so the first solution we have already obtained the first solution, and now let us obtain the second solution. Here you can see that we have, okay. Now if we take the second and third term, then we will have dy upon, now this x will become common, y plus z, and in the right hand side we will have dz upon y minus z, and x is common. Now we can solve these two equations. So that means we have dy upon dz equal to y minus z upon y plus z. Now it is easy to solve this equation, but I do not want to use this method. Okay, let us see what happens. Okay, now let us take the second and third term. Taking second and third term, say this is your first term, this is your second, and this is your third term. We will get dy upon x y plus z equal to dz upon x y minus z, and this will be your dy upon dz equal to y plus z upon y minus z. Now you can see that here the degree of the numerator is 1 and degree of the denominator is 1. So that means this differential equation is homogeneous linear differential equation. So one method is that let us assume z equal to some u into y, and or let us cross multiply these two terms, and I will try to arrange this term. So let us see whether we are able to arrange them or not. So here we will get, from here I will get minus y dz, and then we will have minus z dz equal to 0. So you can see that this is your y dy and this is your z dy plus y dz, and the fourth term is z dz equal to 0. So we have on, now this first term is y dy, and the second term is d of yz, and the third term is z dz equal to 0. So on integration we get, now integration of y will be y square by 2, and here we will have yz, and then the integration of third term is z square by 2 equal to, say, some constant c2 by 2. So this is your y square minus 2yz minus z square equal to c2. So this is your second solution. Thus, therefore our solution is, the first solution was x square plus y square plus z square, and this is your second solution. So this is your complete solution of the differential equation.